Catalyst, a substance that speeds up reactions by providing an alternative pathway for the breaking and forming of bonds. The process often associated with either heterogeneous catalysis or homogeneous catalysis. The heterogeneous catalysis consists of various characteristics, which includes that the catalyst does not dissolve in the reactant mixture. The reaction does not occur in the gas phase or liquid phase, but occur on the surface of catalyst. And last, the catalyst not involved in the chemical reaction, but it dissolves the reactants on its surface.
Now, let's look on a heterogeneous platinum catalytic oxidation of carbon monoxide. Carbon monoxide and dioxygen absorb from a gas phase onto the active side of solid platinum sulfate. In this case, absorption of dioxygen involves dissociations into individual oxygen atoms on the platinum sulfate. The product is then formed by addition of an absorbed oxygen atom to an absorbed carbon monoxide molecule. The final step in the heterogeneous catalytic reaction is desorption of absorbed carbon dioxide into gas phase.
In industry, the heterogeneous catalysis contributing in many essential chemical processes. For instance, the Haber process in the making of ammonia, the contact process in making of sulfuric acid, and many other catalytic cracking that involves gas oil. Somehow, this significant process able to speed up the industrialization era and provides benefits to the public and nation.
Now, let's take a look at some questions and answers on catalysis. The first question is, state the definition of heterogeneous catalysis. Well, heterogeneous catalysis is a type of catalysis where the phase of catalysis differs from that of the reactants or products. That means that the catalyst might be a solid and the reactants or products might be other phase than the catalyst, which may be gas or liquid. The next question is, explain the difference between heterogeneous and homogeneous catalysis in terms of phase. Then, give an example of industrial process which uses one of the catalysis to explain how phase differs from its physical state. Briefly explain the industrial process. The answer is, homogeneous catalysis differs from heterogeneous catalysis due to its catalysts are in the same phase as reactants or products, meaning both the catalysts and the products or reactants are in the same phase, such as both of them are in liquid phase, in gas phase, or in solid phase. So the process that we'll be talking about in the answer is Haber process. Haber process is also called Haber-Bosch process. It's one of the industrial processes that uses heterogeneous catalysis involving artificial nitrogen fixation process, and is also the main industrial process in producing ammonia today. In Haber process, iron is the most common used catalyst because the cost is low for the industrial production. All the reactants and product, nitrogen, hydrogen, and ammonia, are gas, but the iron catalyst is solid. Now we will see a picture of the Haber process. As you can see, in the reactor, there lies the catalyst, which is the iron catalyst. In this process, atmospheric nitrogen is converted into ammonia by a reaction with hydrogen using a metal catalyst under high temperature and pressure. This is the equation. As you can see from this video, the nitrogen molecule approaches the iron catalyst, which then binds to the iron catalyst. And then here comes the hydrogen molecule approaching the iron catalyst and breaking their bonds, and then approaching the nitrogen molecules, which then forms bond between them, forming ammonia molecules, which is then released as product. The next question is, silver and tungsten are not a very good catalyst, but platinum and nickel can be excellent catalysts. Explain the statement above in terms of strength of the adsorption of gases to their surfaces.
Platinum and nickel can consider as better catalysts over silver and tungsten because platinum and nickel are able to split up the oxygen molecules into atoms and do not bind strongly with free atoms. The short distance between platinum atoms in the material make it more effective catalyst by binding weakly with the oxygen atoms. Solid catalysts often work by first absorbing something on their surface. A reaction then takes place, and the products are dissolved from the surface, break away into the gas or liquid again. That frees up the surface for the next lot of reactants to become adsorbed. Silver is not a good catalyst because it is not good at absorbing things on its surface and it does not form strong enough attachment for the reaction to occur. Tungsten is not a good catalyst because it absorbs things too strongly and so does not release the product of a reaction and so frees up the surface again. Furthermore, platinum is widely used as catalyst in industrial field because of its effectiveness under oxygen excessive conditions. Platinum has several advantages as catalyst because it has high melting point, its interaction with poison such as sulfur compound are limited to the metal surface, and lastly, it can be efficiently recycled.
Next question is, in the contact process, the reaction between sulfur dioxide and oxygen is catalyzed by vanadium 5 oxide. Write the equations to show the mechanism of this reaction.
Nowadays, contact process is one of the most important processes to manufacture the sulfuric acid. One of its catalysts used is vanadium 5 oxide. This catalyst is used in this following step. 2 moles of SO2 react with 1 mole of O2 to produce 2 moles of SO3. Vanadium 5 oxide serves as crucial purpose of catalyzing the mildly exothermic oxidation of sulfur dioxide to sulfur trioxide by air in the contact process. The following equations show how the vanadium oxide catalyzes the process. 1 mole of SO2 reacts with 1 mole of V2O5 to produce 1 mole of SO3 and 2 moles of VO2, followed by 2 moles of VO2 react with half mole of O2 to produce 1 mole of V2O5.